Alright, on number 4, this is what we start with. Sine squared of theta over 2 is equal to cosine squared theta. And again, here's a situation where when you look at this, you have something going on inside the parentheses with the theta, and that needs to be your first, the first thing that you do. So when you look at this, theta over 2, so it's half of theta, you should be hopefully thinking half angle. So remember, this can be rewritten as sine of theta over 2 with the squared on the outside. Alright, and that helps because it really helps us see that we're going to replace the inside of those parentheses with the half angle formula, and then we're still going to have to square it on the outside. So if you look at your formula sheet, the half angle formula for sine is plus or minus the square root of 1 minus cosine theta all over 2. Again, that still has to be squared. Is equal to cosine squared theta on the other side. Because this ends up being squared, the square root and the squared are going to cancel each other out because they're inverses of one another. So we have 1 minus cosine theta over 2 is equal to cosine squared of theta. Get rid of this fraction. So we have 1 minus cosine theta is equal to 2 cosine squared. And then we're going to have to set it equal to 0. Again, we want to keep the cosine squared positive, so we're going to leave that on the right side. So 2 cosine squared of theta. If I add over that cosine, and then subtract over the 1. So this is the quadratic that we're going to need to factor. Just like we did on number 3, we can say let whatever variable you want, in this case I'm going to use x, let x equal cosine theta. So we have 2x squared plus x minus 1 is equal to 0. Once you split the middle and factor this one, it actually ends up being the same quadratic as number 3, but it should factor into 2x minus 1 and x plus 1 is equal to 0. Take each factor, set them equal to 0. So for here we get x ending up equaling positive 1/2 and negative 1. Keeping in mind that these were cosines. And we just need to use our unit circle to figure out the solutions to this quadratic. Alright, so cosine is going to be positive in the first quadrant, and then cosine is also going to be positive in the fourth. So we're going to look first and fourth for our answers. Cosine's only going to equal negative 1 one time, and it's going to be at a quadrantal. So if we use our unit circle, we're looking for where cosine is positive 1/2. So cosine is your x-coordinate. So it's positive 1/2 at pi over 3. It's also going to be positive 1/2 at the other over 3 in the fourth quadrant. So pi over 3 and 5 pi over 3. Then we're also looking for where cosine is negative 1. That's going to happen back here. Alright, so those are our 3 answers. We can see from here that they're not going to create the same line. So our final answer is going to be theta is equal to pi over 3 plus 2 pi k. Theta is also going to equal 5 pi over 3 plus 2 pi k. And then finally, theta is going to equal pi plus 2 pi k.
Made with Doodlecast Pro.